let's start with SQL. Please feel free to stop me if there's any question. Right. So for the theory of SQL, this is probably the best website, W3 Schools. For practice, you can go through the medium practice solving, easy medium practice solving questions. I mean, practice questions on HackerRank. You'll find that easily. Then there are other sources. I've seen people learn from Data Camp, Code Academy. There are courses on Udemy and Coursera as well. So you can go through some of them. All right. Now let's try to understand the sense. Where does structured query language come from? Now let's break this down first. This is a language which is a structured language, of course, and we are trying to run some queries. Now, what can these queries do? How can these queries help us? Let's say this is a university database, right? In your college, I'm sure there'll be this kind of a database. Now, the student table, this is a table, and these are the values, these are the parameters within the table. Every student will have an ID, will have a name, a department name, total credits, all of that. And similarly, every student would have an advisor, and this department name column is directly related to the department. Which will, this department name will directly link with this department name here. Now, for let's say there's a department name A, for that we'll have a building and we'll have a budget, that kind of a thing. Then we have again for the student we have grade, year, semester, I think the section ID, course ID, all of that. Then within section ID, there'll be another table which explains, which gives more information about the section, right? Building, room number, time slot. Then within the building or with, I mean, there'll be a separate table called the classroom. Then there'll be tables for teachers. This teacher teaches this course, this semester, this year, all of that. And for each course, you'll have a prerequisite, right? And yeah, this is the instructor table. You'll have a name of the instructor. Let's say belongs to mechanical engineering department. Would be what is the salary of the instructor? What is the ID of the instructor? So this is very related. All these tables are related to each other. How are they related? They are related through some kind of a key. Now this is called a key. This ID, how is the student table related to the takes table? It is related through this single key. This is called a key. And if I'm talking about the student table, this is called the primary key, right? And this is called this is called the primary key. This is called the foreign key. If I'm talking about the takes table, this becomes my primary key. And if I'm referring to this student table from the takes table, this becomes my foreign key. So this primary key and secondary key, primary key and foreign key concept, I want you to go through, right? I'm not going into a lot of depth here. I'll move on to the types of databases and the code part, all of that. But I think you can, this is a very simple concept, foreign key and primary key, just go through it once. Any, even Wikipedia would work, any website would work. Now, there are a few types of databases. There are relational databases, NoSQL database, distributed, object-oriented, operational, centralized, cloud graph. All these types of databases are there. We'll be dealing with relational databases mostly, where data is stored in multiple related tables. Now you saw here, right? These are multiple tables. Each table is related with some other table through some key. I think till here makes a lot of sense, right? If there's any doubt, feel free to stop me. Now, Relational Database Management System, RDMS, allows you to create, update, and administer a relational database. So basically, this RDBMS kind of thing, this helps you to update each table or make changes to a table, create a new table, drop a table, I mean, delete a table, right? All those operations are possible through this Relational Database Management System, RDBMS. Then for again, NoSQL is also kind of important. So I've explained this also. What's the difference? Data in a NoSQL database doesn't have to conform to a predefined schema. Now, what do I mean by a predefined schema here? Now, this all these tables have a schema. This student table will only take 4 values. It will take the ID of the student, name of the student, department name, total credits, all of that. Now, a NoSQL table, you can even add things here in this database. So it doesn't have a predefined schema, and developers can make changes to the database on the fly, right? I've not worked with NoSQL databases myself, but I've heard that it helps the people be more flexible. So that is there. These types of databases are great for organizations seeking to store unstructured or semi-structured data. If you notice, relational databases are structured data only, right? All this data is very, very structured. We have tables. Within a table, we'll have columns, right? Let's say this is a table. Let's take the student table. We have the ID of the student, right? This is a column, and then we'll have student A, B. Many, many students would be there. Then we'll have name of the student. Then we have the department name. These are columns essentially, if you see it that way. Then we have number of credits, total credits, this, right? So that is very, very structured. This is a relational database. And there are a few popular databases. MongoDB is one. Then PostgreSQL is there. We most commonly use MySQL. MySQL is used very commonly. Whenever I think most of the times when you code, you'll be using MySQL only. And this is open source. That is one of the reasons people use it, and it's very reliable that way. And I think you'll get to know the advantages when you use it. It's very straightforward. MongoDB, PostgreSQL are also very widely used, so might want to learn more about them. Okay, so these are a list of topics that we need to study within within SQL. I'll just open document. Are there any questions till now? Feel free to ask if there's anything while I'm opening this SQL sheet. All right. So I'll not be using slides here. There's a very good cheat sheet made by a company called Data 365, Data Science 365. I'll be using that. All right. Can you see my screen? Can everyone see my screen?
Yes, sir.
All right. So okay. So we'll start with the very basic queries here. Now I'll just quickly walk you through this sheet. I will be sharing this sheet with you tomorrow or today, and you can go through this sheet at your own pace, right? And I think this covers everything. Now, if you notice, this is I think this is a well-known data scientist, and he's mentioned that he has added everything that you will need as a data analyst or as a data scientist. And I myself found this sheet very useful. It covers everything, right? This PDF, I mean. So let's start from the basic queries. There's this query called select. Now, first of all, would like to understand one thing before I start with this. How many of you have some idea of SQL? How many of you have learned SQL before? Put a yes in the chat box. That will be more helpful. All right, 1 second. Let me quickly understand the uh, the demographics through this poll. I've launched a poll. If you've learned SQL before, then select yes, otherwise select no. Okay. There are a few people who have. I want more people to vote. There's, I'm not judging anyone, of course. I'm just wanting to understand what's the level of SQL understanding here. Okay. So there's a 40-60 kind of split. 60% people have not learned SQL and 40% have learned SQL before. All right. All right. Right. So let's start with the select statement. Right. Now the select statement is essentially that this helps you to return every column and every row of the table. Now, suppose I select star. Star means that I'll be selecting every column and every row, right? This will return the entire table. So the select star from table name. Table name is the name of the table, right? Everything is very explicit here. Everything is very implicit. You'll be able to understand. So table name is the name of the table. And when I say select star from table name, it means that I'll be returning every column and every row. I'm selecting all the rows and columns of the table called table name. That is select star. Now, if I run the same query and I just put limit 10, it will just return the first 10 rows. So limit 10 basically limits the number of rows that we are returning. Not the columns, but the rows. So it will limit to the first 10 rows, right? Now, suppose I do not want to return all the columns and all the rows. I just want to return some specific columns. I just want to see some specific columns or make changes to them. So I'll basically write select and I'll write the name of the column, right? Column 1, column 2. So every table has, these columns and every column has a name, right? So you can write the name here and you can just write from table name. Again, the same thing. So this is using the select statement. This is the most basic statement. Every query would have this. In SQL, then we have more than 40 different types of data types. You'll come across these most frequently. So integer is basically a whole number without a fractional part. These are examples. Then decimal is the decimal number. Boolean is either true or false. Then we have date. This we can change this format, right? So this is the date. Then we have time. Again, we can change the format of this. This is the time format. Then we have the entire timestamp. Let's say in the Google form that you filled for the assignment, there was a timestamp column. Which person did the assignment when? So that was this timestamp column is very helpful for understanding the exact date and time when the person completed the assignment or did whatever specific thing to. Then this timestamp again is I think in SQL we use this very frequently because we are dealing with a large quantity of data and there's totally possible that we are not able to keep track of the exact date and time. And in all the data sets that I've used, I've come across this very frequently. Then of course you have string or text. for example, hello or whatever we want to write. And this text kind of thing can accept any kind of value, right? So one can also be stored as a text. An integer can also be stored as a text, or a boolean or a decimal. Everything else is text. Boolean cannot be stored. So if you write true, and it will detect the this value as a boolean only. So text is a universal kind of flexible kind of data type. All right. Now, suppose I just want to return a specific column when some condition is met. That is where I talk about horizontal filtering. This is where we use the where clause. So what this will do is that it will select all the columns and all the rows from this table where the value of column 1 is some expression, right? So when the value of this column is equal to this expression, so that will be that is the use of the where clause, and it will return every column from the table name, but only those rows where the value in column 1 is equal to the expression, whatever I write here. Let's say I write 10 here. So whenever the value is 10, it will return that row, right? And this can be something other than text, a number, date, or any other format. So column 1 equal to any of these formats. Then we have advanced filtering. Now all this is filtering only. I'm talking about filtering only. So here we have other operators. For example, equal to, this is not equal to, this is also not equal to, and we have less than, equal to, all these operators. And these help you to compare two values, right? Let's say this, we want to check if the value of column 1 is equal to, here also I've used this operator, right? Equal to operator. Similarly, if the value in column 1 is greater than some value, then we can use this operator. And very implicit, I think you can understand this. So this helps us to filter. Now there are two specific operators. One is like. If the column 1 is like, the value in column 1 is like something, it means that this works very similar to equal to. So like expression, this means that it contains this word, right? This like expression means that it contains this word. And if I write in, then it will mean that this, if the value of column 1 is in either of these, is either experiment 1 or experiment 2 or experiment 3, right? If the value is within this, within these values, it is one of these values, then we use in. These are two specific operators. Others are very simple, very frequently used in other languages also. And these are two specific operators specific to SQL. This is filtering. If there's any question, please feel free to go ahead. Right. These examples make my work easier. So I wanted to explain you the usage of these operators. So this statement, right, select star from table name, means that I'll be selecting all rows and columns from this table where the value of column 1 is not equal to this expression, whatever expression I write here. And it has to be in single quotes, right? That is expression. I mean, that is the use of this operator. And this query returns every column from table name, but only those rows where the value in column 1 is not expression, right? Similarly, value in column 2 is greater than equal to 10. That is again very understandable. Then where column 3 is like xzy, which means that the value in column 3, right, is it can be anything. It can be, let me type in the chat box, it can be something, then x, z, y in between, then something else. This kind of a value is also possible, right? So how do you understand that this kind of value is possible? So these percentage operators, right? These are called wildcard characters. And what do they mean? They mean that there can be any value in front of xzy and after this this small term. There can be any value before this and after this. It just needs to contain x, z, y, these three letters, right? So if the value in column 3 is like uh, this expression, then it will return that. We'll be able to see those rows and columns. So that is the use of percentage. Again, this percentage wildcard. If you have now, there's one more operator. It's the underscore operator. The underscore operator can be replaced by only one letter, but the percentage operator can be replaced by many letters, right? So for the for example, the I gave you an example in the chat box, right? This is also a possibility. It can return this as well. So you'll if there are any questions, please let me know, because this might sound a bit over the top to many people, because this is totally new and totally that is totally understandable. But I'll share this PDF with you, and there's no reason to worry, because initially I also found it a bit difficult, but it's just that you need to practice a bit and go through some theory. That is all. Then we have multiple conditions, which means that again we are talking about filtering only, but here we have more than one conditions. It will return the rows and columns if the value of column 1 is equal to this expression, and if the value of column 3 is like this, which means that xzy has to be contained in the value in column 3, right? That is this. And then we have similar expression. Now this and means that this and this both need to be true, right? And this or means that either this can be true or this can be true, or both can be true. So that is or. So this and or, I think you are familiar with these things. Then yeah, I mean, here they've just mentioned that we need to properly format this. Uh, so there's a proper order that we follow. Select star from table name. Now from is a keyword. Similarly, select is a keyword. Where is a keyword. And is also a keyword. Limit is a keyword. So you might want to keep these in capitals. Second thing is that this all of this is one expression, right? Where this and this. Now where is the keyword that we are using, and all of this is one expression where this is true. So here either you can keep all of this in the same line, or if you want to keep them in separate lines, then you might want to format this properly. You should format this properly here, right? So that you understand that all of this is one query.